computer. Okay, going kind of a little backwards in the Gaddis book. Today we're going to hit two topics, exceptions and templates. Both of them are mid-level topics. Neither one is long, but we can do two of them in one class, so that works out really well. A lot of exception work is going to be done in CPS 230, but we're also doing it here in 162 to show you that it'll work in both C++ and in Java. Okay, so a big thing about this is what happens if you're writing a program and for a reason, and there's a bunch of different reasons, you get an error that crashes your program. And here's a big one. Divide by zero error. Please enter the numerator, please enter the denominator. Um, the dividend is numerator divided by denominator, and somebody puts in a zero. And we would get that division by zero error. Now we can handle that. Oh, that's a good word. We can handle that down here. It comes in to play with an if statement. There's an if statement. Oh, well, if the denominator is zero, we kind of caught the mistake. Oh, there's another word, catch. We were able to catch the mistake. And these are words that are going to be used when we're talking about exceptions first. So an exception is when we get these, let's see, we had syntax errors, we had logic errors, and what was the third group? They were called runtime errors. Okay, I was pointing to running. Runtime errors. Okay, now when this runtime error occurs, this thing called an exception happens, and an exception is thrown. In 230, CPS 230, when this exception happens, you're going to learn that an object is instantiated. Okay, an object is going to be instantiated from a class, which means there's a class somewhere that gets involved when this happens. Now, it can just crash the program. The class will say, hey, the program crashed because you had this type of error. All right. So coming back, we're going to get into this whole when this runtime error occurs, we're going to get an error and an exception is thrown. And when that exception is thrown, we'd like to be able to handle it. Now, how do we handle an exception? Well, we're going to use this thing called a try catch construct. A lot of times you're going to hear a try block and a catch block. You're going to hear same terminology in C++ as you will in Java. So we're going to spend some time, but what I want you to do is go to D2L and download the zip file that I gave you for chapter 16. Once you do that, I would like you to pull up program 16.1. I'm going to be doing a lot of book work today. It's really interesting. I get all this crazy code and everything. And I had a student post an assignment solution in another class. And funny, he worded it. I used everything taught in the class and what's in the book to be able to solve this problem. I did not have to go to the internet to figure it out. I thought that was kind of interesting. And you know why? Because I recently had three students and a plagiarism issue. Okay, so you have code in front of you. Hopefully you opened up 16.1, and we're going to come in and take a look at what's going on here with 16.1. Oh boy, I come in and nothing's out of the ordinary. Shooby dooby dooby. Here's the function prototype. The function prototype is divide. And I'm going to come down and I get two numbers and I'm going to call that function divide. Now, this is going to be the area where a potential error can occur. Lines 22 and 23 go together and could get funky. This is a block of code, and that's why it's commonly referred to as my try block. So I come in, shooby dooby. Oh, it says, oh, hey, try, how you doing? Compiler keeps going, quotient equals, and it goes to the function divide. Now, check out the function divide. I bring in numerator, denominator, and I'm going to return a double. And down here, we have some casting going on because we want double division, not integer division. So we make numerator a double real quick. But if denominator equals 0, I'm going to get ready and I'm going to create this string called exception string. I could call it anything I want, error message, could be a lot of different things. And then I'm going to throw it. Now, what I just did was I threw a string up in the air. It's up in the air. So if everybody had a different shirt on and your shirt says string, and I threw the string up in the air and said string, you would want to go try and catch it. Well, because I threw it up in the air, I come and say, oh, line 25 is the one that's going to catch that string. Again, we could call this just message. We could call any name we want. But once it gets thrown up in the air, it gets caught in line 25, and then this line executes. See out whatever that string was that was thrown up in the air. So all I did right now is throw a string up in the air, and I caught it because I didn't like what was going on in quotient, and I didn't want my program to die. As we move on, you're going to see there is rectangle.h version 1. And of course, it has a spec file and an implementation file to go with it. Get it up, get it running. That way you see the whole. Now we're going to talk about the parts and then put the whole back together. All right, the spec file. Starting to become second nature. All of a sudden I come in, I see I have width and length. We've dealt with this darn rectangle class so much, but it's a great one to explain things. And all of a sudden I come in and what's going on in lines 12 and 13? Anybody? Okay. 12 and 13, I'm creating a class called negative size. So now this, I don't think we've seen this before. I'm getting ready to work with a class called a rectangle. And within the class, I'm creating another class. This class is called negative size. Spec file. Implementation file. Inside of my implementation file, I am, what's going on in line 13? What is negative size?
So is that if the area of the actual like rectangle is negative, it throws the error that you put in some negative number?
I mean, yeah, probably. I didn't read all that yet.
Oh, okay. I was
You're
looking.
actually you're actually right, but not having read that yet, What is this I'm throwing? What does
An
it look like?
exception.
A what?
An exception.
An exception. Yeah, I'm throwing an exception, but what is negative size? What was this guy over here? Negative size is a
A class.
plus. Yeah. So this guy, when I call this, I'm kind of calling an object of this class. Not really doing anything, didn't even give it a name, but I'm throwing a negative size. So when this function gets called, if width is less than 0, I throw this negative size. Okay. So earlier I threw a string. Now I'm throwing something a little bit different. All right. Kyle gave us the update of what's happening with the actual code in that function set width. So let's see what's going on in here. I come down here, my rectangle dot set width. Now, if a negative number was entered over here, so we enter a negative width and we go to set the width, it jumps over here. If it's negative, it's going to throw a negative size. Well, if I'm throwing it, that means I need to catch a negative size. Negative size is inside the class rectangle. So I'm coming in here. I go to set the width. Back over here, if the width's a problem, I throw this negative size, which is part of a class inside of rectangle. So this catch line, especially in 230, is going to have a lot of stuff in it. Catching specific things. Okay. Catching things from classes that already exist. Again, that's a 230 thing. All right. Questions? What about version 2? Version 2. I don't know why I repeated myself. You can look at version 2. 2 is not a version. Version 2, I have multiple exception classes. I am writing something called an exception class. That's the terminology you're going to hear me say. Write an exception class to blah, blah, blah. Here's multiple exception classes. They're listed before the constructors. Rows negative width, rows negative length. We have different ones. And in fact, you can see we have different catches. We have a catch just for negative width. We have a catch just for negative length. After we talk about templates, we're going to come back and you're going to make your own exception class. A little bit to wrap your heads around, right? Now, growing, getting bigger. The jackpot is getting bigger. Here's the same thing we just saw, a try block. You know, I'm okay. It's good. We set the width. The width was good. And I have a try again equals false. I have a Boolean. This is in a while loop. And it's going to stay in here until this executes correctly. And when this executes correctly, the try again becomes false. Otherwise, I come in, I found there's an error. I go into this catch block. I'm catching that negative width. and I'm saying, oh, get a new number. And this is the advantage of having these exceptions being handled within the program because I can go back up and keep the program running. The program doesn't die. Could we do a lot of this with if statements? Yes. But these are baby steps on how these try and catch blocks can get bigger and bigger and bigger. And here's one. If they enter a bad width, I can catch it and keep going. Oh, imagine showing this to a first year comp sci student, let alone a non comp sci student. They have no idea what's going on. All right. So now, what if I wanted to get and say, hey, you entered a negative number? Well, that's fine. But what was the negative number that you entered? Ta-ta! Version 3. Version 3. You know, we have this Wednesday's class. We're off Monday. Next Wednesday is the middle of the semester.
Goes fast.
And they all go fast, trust me. All right. Oh, I come into my specification file and I'm inside of that class and I say, oh, here's my class negative width. Good. I have stuff going on in here. When I throw an exception to negative width, I'm now including a constructor, and the constructor is going to receive that value coming in. It's going to assign it the value. And if I want to know what that value was that's now stored in this class, I have a function called get value so I can go get it. I'm sending something in and I have all this that I can work with. I'm sending something in down here, cut and paste. I can get it if I want to. Oh, so let's go into this first try block. Set width, set length. I come into set width. Shooby dooby doo. I go over to set width, and you notice this time, instead of calling negative width, I call it with an argument. What was that bad number? And then in the class, I can store it and get it if I want to. So that if I go into that class and I caught this object, okay, now it's an object because there's a lot more going on. It's common to see it as little e. You can give it any name you want, but it's an object of the negative width class. Why do you think they call it little e?
Error.
Error?
Yeah.
Exception?
Oh yeah.
I don't know. That was a ambiguous question. I don't know if there's a right or wrong. But they use E, the letter E. Here they on that object, they call the function get value, and shooby dooby doo, they use it for whatever they need it to use it for. I'm not in a loop, so I come out of here. I'm not catching a negative width. I come out of there. It would print end of program. Questions? Questions. Okay. Part two. That wasn't too bad. That was a fast 27 minutes. A function template. So we're going to start out working with just functions and look at a function template. And I'm Mr. Snow Miser looking for my notes. A function template. In my notes, I have written down it's a generic function. I can work with it just about any data type there is. It's referenced to be considered it's a mold, not something growing in the closet in a back room. not that kind of mold. For example, what if I wanted to have a function called square? This function brings in a number. Yeah, that was on the most recent test for 161. They had to make this a reference variable, and this was a void. And not too many of them got it right. You folks as 161s did much better on this first test than this group coming through. So I need to work hard on them. Okay, so this is not a reference variable. I'm returning a value. I'm bringing it in, and boom, I square the integer and return it as an integer. Well, what if I said I want this to work as a double as well? Well, we would copy and paste and put the word double in. What if I wanted it to work for a long? We would copy and paste and put the word long in. What if I got tired of that and I wanted to say everything's the same? It's like a mold, except what I put here and what I put there. And I can take care of it. First thing I do is I include this line template, class, and I'm going to use capital T. Could use what I want, but I'm going to use capital T. What this is saying is whatever this is, if it's an int, this is going to be an int. If this is a double, this is going to be a double. These are always going to be the same. That's nice. That's a test question right there on the next test. Write a template to blah, 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 blah. Oh my. Let's look at some code and see what's going on in here. 16.7. There it is. There's square. Nice and simple. That's the template we just talked about. Other things we can do with templates. Check this one out. Nice. I have a swap. This swap, there's that line 5. This swap is going to work for 2 integers, 2 doubles, 2 shorts, 2 longs, to whatever variable or data type we want to put in there. I get a temporary variable and I do that 3-handed swap. Remember when you first learned about how to do this? It was crazy trying to keep that straight. Now you have linked list you're trying to keep straight. And on Wednesday, Andrea will be happy when we do doubly linked list. She's been waiting for that. Yeah. All right. So there's another example to be able to write this function as a template. Oh, we keep going. What else we got going here? Oh, we have T1 and T2 coming in. What is this template doing?
Comparing the
looking at
values.
the
Hang on, Isaiah, go ahead.
It's what's face comparing the T1 and T2, and then if variable 1 is larger than variable 2, it's going to return that as the largest, and if not, it's going to return the other variable.
Close.
it's the size, like the number of bytes that that particular variable takes up.
Yeah. Yeah. So if the first one, T1, is an int, T2 is a double. When I go down and do size of the first one, var1, which is the int, I'm getting a return of 8 bytes, 4 bytes, 4 bytes. The second one is a char. The size of the char is 2 bytes. So it's going to return 4 or 2. In this case, it's going to return 4. Kind of some clever code. If you look down here, they're using C out. They're using ints and chars and floats and doubles. But being able to read this and go, oh, yeah, we saw size of a couple of times, but not very much. Boom. Overloading. Overloading is the same.
Name, like function name, but with a different list of parameters.
It's another word for list of parameters.
Arguments.
Signature.
Signature. That's it.
Signature. Yeah. Yep. And here we go. I have some with 2 in the parameter list. I have some with 3 values in the parameter list. Different signatures. So it knows which one to use. Well, that's kind of nice. Just tying some things together on what you can do. Okay. Questions. Questions. And we talked about it the other day. You can even have programs that are templates. And we saw an example or two of that before. All right. What are we going to do? Going to put you in groups. I think we have plenty of time. And I want you to write a program. Well, not write a program. Go back to that rectangle program. This is the rectangle program. And
Which version?
the version, I don't care, version 2 at least. Make sure I would go with 3. Go with version 3. Now, in that rectangle program, we had an exception class for negative size. I believe there one was not negative size. I apologize. Negative width and negative length. I now want you to write an exception class that will catch if the area is over 100. So you're going to have to make a new class in the spec file. You're going to have functions in the implementation class, and then you're going to have to update the demo. You already have 2 exception classes. I want you to create a third one. That third one is going to use the length and width and multiply them together. If it works, great. If it's over 100, not so great. I want to print out a message that says, oh, no. Your area is blah, 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 way too big.